in this video we're going to talk about organic chemistry. Now you do well to subscribe to our channel so that you don't get to miss out on all the contents that we share. Now we're going to talk about alkanes, alkynes, alkenes. We're going to talk about all these concepts. We're going to talk about alcohols, amines, ethers, ketones. We're going to talk about all these concepts. Then also how you deal with several functional groups, the properties of some of these organic compounds that we're going to talk about, the nomenclature, how you name these organic compounds, then how you present them in terms of molecular structures. Then also going to go through some IUPAC rules that you should follow when you are naming all these compounds. So basically this is how we are going to go. So what are some of the basics that you are supposed to understand before we even go deeper? So I've just separated everything just to make it easier for us to follow through. Okay, so basically all these concepts we're going to talk about them. So what is organic chemistry? Okay, in simpler terms, we're just talking about the study of organic compounds. Then what are organic compounds? Any compound that is going to contain a carbon in them. Okay, mostly when you have a carbon and a hydrogen, those ones are organic compounds. Now an exception can be molecules like if you let me say I've got a carbonate. Okay, this would be an exception. However, if you have carbon and hydrogen in that compound, then you have an organic compound, or which we are referring to as a hydrocarbon. Okay, even just the name itself suggests, so you have a hydrogen and you have a carbon in that compound. Now most organic compounds, they react with oxygen, okay, in a process called combustion reaction. So what you should understand is that let me say I have an organic compound, and this organic compound, it reacts or it burns in oxygen. Okay, so an organic compound reacting or burning in oxygen is going to give you carbon dioxide plus water. That is very, very important for us to understand. Now we're going to talk about a lot of organic compounds here, so you would want to pay particular attention to what we are going to be focusing on. Okay, but before we even just start talking about these organic compounds, it is very fundamental that we understand the IUPAC rules. So the IUPAC itself, it is the International Union of Pure and Applied Chemistry. So we're talking about International Union of Pure and Applied Chemistry. So that is this board that comes up with rules about how you name compounds, because we want to have a uniform way of how we are naming these compounds. Now for me to just explain this one fully, I've broken it down to we're going to talk about the parent compound, what it is and how you're going to deal with it according to the rules provided by this board. Then also going to talk about some of the functional groups, the key functional groups, as far as much as your course is concerned. Then how you number these organic compounds. Then also some of the substituents that you're supposed to focus on. So basically this is how we're going to talk about the IUPAC. So what about the parent compound? So according to the IUPAC, you have to first and foremost identify the parent compound. Okay, so that is very, very important for us to understand. And in this case we're talking about to identify the longest one. Okay, the longest chain which has continuous carbon chains. Okay, that is a parent chain. So an example that I can give here is, let me say this is a chain and it's going like that. Okay, as an introduction. Okay, if going like this, if I was to name like 1, 2, 3, 4, that is one route that I can take. Another route that I can take is 1, 2, 3, 4, 5. Now I'm able to see that this route, which goes like this, it has the longest chain of carbons. So you are always going to get the one with the longest chain. In this case, this direction. Okay, so that is very, very important for us to understand. So it is one of the fundamental rules that you are supposed to just not forget. Okay, so and after you've determined the parent chain, number 2 on the parent compound, you have to also determine the parent name. Okay, so that longest chain, you're going to identify it. Okay, so based on the type of organic compound it is, you're going to name it. If is it methane, is it ethane, is it propane? Okay, so we're going to talk about some of these concepts as we are going to proceed. Okay, that is very, very important for us to understand. So what do I mean? If this is okay, this is butane, therefore it's a chain of 4 carbons. Now what you should understand is that like in our case we had put like C and C. Okay, in this case our longest chain, this would be 1, 2, 3, 4, 5. So if this is our longest chain, so our name, at least in this case, it is going to be what? Because it's 5, it's going to be pentane. Okay, so that's how our name should end like that. And that is very important because we are considering the longest chain and the its parent name. That is very important for us to understand. Then you're also supposed to know functional groups. Now functional groups are what it's what is going to give the characteristic of a certain compound. Okay, so in this case, according to the IUPAC, you have to identify the functional groups that are present. Okay, functional groups like OH. Okay, and we're going to talk about these functional groups like a carboxylic acid, functional group like an amine, like that. So these are very, very important for us to understand. Now after you've identified these functional groups, number 2 is that you're supposed to you have to use prefixes or suffixes according to the functional groups priority. And now we're going to talk about priority as we're going to move on. Okay, although some of the key suffixes, that suffix comes in front of a number, in front of a letter. Okay, a prefix, a suffix. Okay, a prefix is before, a suffix is after. So that is very, very important for us to understand. Now if I'm going to talk about suffix, they are usually at the end of a letter, or let me say they're usually at the end of a word. Okay, so that is very, very important for us to understand. So if I'm going to talk about suffixes and prefixes, so these have to be identified first and they have to be written first. Okay, because these are like the groups that are going to be attached to our compound, like that. So some of the common suffixes that I can give is, if we're going to talk about alcohol, if we're going to talk about alcohol, so this suffix at the end, all your names or all your compounds are going to be ending in OL. Okay, propanol, butanol, and we're going to talk about such things as we move on. Then we're going, let me say you have an amine, an amine is going to end in amine. Okay, that is very important. If you have an aldehyde, An aldehyde is going to end in al, okay? So that is very important. A ketone is going to end in 1, okay, or one. Okay, then you can have also, alkenes, which we're also going to talk about in detail. So alkenes, IENE, okay, that would be its suffix. Alkynes, we're just talking about YNE. Basically, these are some of the things that you're supposed to understand as some of the common suffixes that you're supposed to know and understand. Then, on the prefixes, these ones, they're going to be used, for substituents. So, what do we mean? Examples like, a methyl as a group. You can have, an ethyl, like that. These ones are very, very important for us also to understand. Okay, so basically this is what you're supposed to understand on functional groups. Now we're going to talk about functional groups in a bit detail. Have I given okay, so you're supposed to understand that about functional groups. So allow me to wrap this part. We're going to use it just to put some functional groups. But before I talk about functional groups, how do you number? Okay, so when you're numbering these organic compounds, you number the parent chain to give the lowest possible numbers to. So number 1, you are numbering the parent chain to give the lowest possible numbers to. You're going to start first with the functional groups. B, you're going to talk about the substituents. Then C, you can also consider the double bonds, if you have double bonds in that molecule, or also the triple bonds, okay, their position. So basically this is the order that you're going to be going. First, look at the functional groups, at their functional groups, identify them, the substituents, then the double bonds. Okay, so basically these are some of the things that you're supposed to understand. And then on substituency, we're just talking about the groups that you're going to be having. Okay, now substituents are of different types. You can have alkyls. Now alkyls in this case, we're talking about things like a methyl, an ethyl, like a propyl, a butyl, and the list goes on like that. Okay, then other substituents that you're going to have, you can also have halogen. Okay, halogen substituents. So what are we talking about? Halogen, these these are mostly electronegative elements like fluorine. So we're talking about fluoro, we're talking about chloro, you're talking about bromo. If you have maybe a bromine attached to one of the as a it will be a group like that attached to the chain. Okay, so basically these are some of the substituents that you're going to have. You can also talk about the aryls. Okay, now aryls, if you go deeper into chemistry, although in some courses you're going to also find the phenols. Okay, things like naphtha. Okay, basically these are some of the things that you're going to find. Okay, so what are you supposed to now understand on these substances? One thing that you should know is that these substances you are going to be using prefixes. Okay, For substances like, let me say, chloro, bromo, you're going to be using prefixes. Then the other thing is that you have to indicate the position of the substituent with a number. Okay, so what do I mean? So if let me say this is our chain and you've named it like this is 1, this is 2, this is 3, let me say here there is let's say chloro. Okay, this is 4, this is 5, this is 6, this is 7. Basically, after you've numbered your chain, your longest chain, you're also going to consider the position at which this substituent is. Chloro is at number 4, so we're going to say 4 chloro. Okay, now that is very, very important for us to understand. So that is important for us to understand. Now before I even go about that, there are other things that you're supposed to understand. So I wanted to answer. I also wanted to indicate that if I have a chloro here, I can have another chloro on position number 5. Now the fact that there are 2, in this case we're going to have a di. Okay, di chloro, because there are 2. If there are if there are 3, we're going to use tri. If there are 4, we're going to use tetra, like that. Basically, this we're talking about multiple substituents. Okay, and that is very important for us to understand. Now that you've known how to name these substituents, how do you now what are some of the rules that you're also supposed to know? You're supposed to know that you use, number 1, you have to be using commas to separate numbers. So you're using commas to separate numbers. Okay, so what do I mean? So if on position number 2, and let me say on position number 3, we have methyls. Okay, so in this case I'm going to put 2,3 dimethyl. Okay, then that is very important for us to understand. You are using commas to separate numbers, like we've indicated here. Then another thing that you're supposed to understand is that you use hyphens to separate numbers from words. Okay, as you had seen, like we had 2,3. Now when you're going to methyl, we have to put like a hyphen or a dash. Okay, so in this case, if it's dimethyl or methyl, but as long as a number is following a word or a letter, you're going to be using a methyl, or you're going to be using a hyphen. Then number 3 is that you're going to be using parentheses for complex substituents. Although this one is not mostly common. If let me say I've got a big group, okay, a very, very big group, 2, let me say methyl propyl. Okay, this is a very, very big group. Okay, so basically you just want to put it like that, and that is very, very important for us to understand. Okay, okay, so those are some of the things that we're supposed to understand. Okay, now that we've talked about some of these, what are some of now the functional groups that you are supposed to understand? Okay, so about functional groups, we earlier said that these ones are going to be a part of that molecule which are responsible for the characteristic of that molecule. Okay, now the characteristics, both the physical and the chemical. So let's start with the simplest ones. So you can have a substituent group, an alkene. Okay, an alkene, which we are going to talk about when we start talking about organic compounds, okay, or hydrocarbons. So an alkene has a double bond, okay, so that is an alkene. Number 2, you can have another functional group that comes from an maybe even an alkane if you want, but basically we're not going to put an alkane because it doesn't have a double bond. It can be just like that, okay. So let me put an alkyne. Now an alkyne, it is going to have a triple bond, okay. That can be a triple bond like that. Then you can also talk about things like an alcohol. So how is an alcohol going to present itself? So you're going to have a hydroxyl. Let's say this is a carbon chain, okay? Then it is attached to an OH. An OH in this case is a hydroxyl, and that is making it an alcohol, okay? Then you're also going to have, you can also have an ether. So basically we've said these ones are going to be giving you the characteristic of that compound. So when you have two carbon chains, okay, 2 hydrocarbon chains, and you have oxygen on the middle, okay, this is going to be or make an ether, okay. So if this is a hydrocarbon chain, you have an oxygen there, then a hydrocarbon chain continues on the other side. So basically that is it about an ether. Then you can also talk about carbonyl groups, okay. Okay, carbonyl groups. Now there are 2 carbonyl groups that you're supposed to know. You can have what we call an aldehyde. Okay, so the way an aldehyde looks like, so there you have an oxygen, so you have an other group or any group, then you have a hydrogen like that. This is an aldehyde. Then another carbonyl that you're supposed to understand is a ketone. So a ketone, not very much different from the the aldehyde, okay. So you're going to have an oxygen there. However, you're going to have 2 other groups, or 2 groups attached to this oxygen, okay, or that carbonyl on top. So basically this is a difference. It's just that this one is going to be found inside a compound, the other one is going to be found at the end of the compound, okay, and that is very, very important for us to understand. And the other one, that means I'm talking about the aldehyde, okay. Basically that is very important. Number 7, you can also talk about carboxylic acids as a functional group, okay. So in this case, not very much different. You have a carbonyl there, this is attached to an R group, then you have an OH, okay. So that is a carboxylic acid. Then you also have to know an ester. Now an ester or an ester, in this case you have a carbonyl, okay, attached to an R group, then you're going to have an oxygen, then you're going to have another hydrocarbon like that, or any chain that you're going to have. Then you're also supposed to know an amine. So an amine, you have a nitrogen there, okay. Nitrogen usually have lone pairs like that, and you have an R group like that. Number 10, you're also supposed to know amides, okay. So note the difference. The previous one was an amine, this one is an amide, it has a D. So in this case you're going to have something that looks like a carbonyl, you have an R group, Okay, then you're going to have an NH2, an amine group. Okay, so that is very important for us to know. Then you can also have an acid halide. So an acid halide, so you have, let's say, an oxygen there, then you have an R, then you have an X there. So that is an acid halide. Then you can also have a thioether. Now a thioether, you're talking about, you have an R there, but you have got a sulfur on the middle. Basically, these are very, very important for us to understand. Okay, now earlier I said all those compounds that we talked about, the functional groups which give the chemical characteristic and the physical properties of a particular element, or let me say compound. So what are you supposed to understand? There is a priority list on those functional group in case they are found in one compound. Okay, so which one are you going to prioritize first? Okay, so basically, okay, so you can use a very simple mnemonic. So okay, these are just the way they are in terms of words. Okay, so I'm just getting the first letters, CA, EA. Then what I'm going to do, I'm going to write anaka. Okay, anaka. Okay, anaka, like that. Then the last words are E triple A. Basically, these are this is our priority list. So the first one we're talking about a carboxylic acid. So in a compound, if you see a carboxylic acid, we are going to prioritize it. Okay, and you said these ones said they end in oic. Okay, so a carboxylic acid, if you see a functional group that looks like this, you are going to prioritize it as opposed to the other ones. Okay, so let me say this is a compound. Okay, you have an OH there, let's say, and you have this group, the COOH. So if I've got a COOH, I'm going to make sure that I name my name base, it will end in oic. Okay, not in as an alcohol or L. No, I'm prioritizing that. Okay, so that's what I'm talking about. That is the priority list according to the IUPAC. Then after you have a carboxylic acid, what follows is an A. Now these ones are called anhydrides. Okay, now anhydrides, let's say I've got a C there, an O, a C, and another group being attached there. So basically it is very important that you understand these ones. Okay, and then you have an E. Now an E, in this case, this one, it is an ester. So we're talking about esters here, sweet smelling your perfumes, like that. Okay, so in this case we're talking about what is this? You're going to have a carbon, or let me say CO, then you have one O, and you have another group like that. That will be an ester. Then the A in the other case, this one, we're talking about acyl halides. Okay, so acyl halides, let's say you have a CO, this is being attached to a halogen. Okay, in this case you can have fluorine here. If you want, you can also have another, group 7 element. You can have chlorine there. You can also have, you can have bromine, and the list goes on. You can have iodine there. Basically those will be acyl halides. Okay, now that I've talked about these ones, what about the other part? Okay, this A, we're talking about amides. So amides, the formula, like you have CO, this you're talking about NH2. Okay, so you have an amide group. We're talking about amides. There's a D there, so mind on how I say it. So these amides are also called lactams. Okay, that is very, very important also for us to understand. Now what about the N in this case? The N, we're talking about nitrous. Okay, so things like cyanide. Okay, that is very, very important for us to understand. Then we have another A here. So now here, that's where your aldehydes come in. So aldehydes. Okay, so you have this group. Okay, so basically that's what your aldehydes will be. We have a K here, ketones. So you're able to see that aldehydes are more prioritized as opposed to ketones based on this listing. Then an AA in this case, this is supposed to be an alcohol. Okay, so let me say this is an alcohol. An alcohol in this case, we're talking about OH. So basically that's how you're going to prioritize that. Okay, and then after this you're now going to have amines. So amine NH2. Okay, that is an amine, and that is very, very important for us also to understand. Mind you, just to remind you, we were differentiating it with an amide. Okay, an amide, we are just differentiating with an amide. An amide here, we said you're going to advance a CO, then this is where now you're going to attach your NH2. Okay, that is the difference with an amines. This one we're saying is an amide. Okay, basically that is very important for us to understand. Okay, now what about the E in this case? Since we've already talked about these ones as esters, these ones are going to be called ethers. Okay, so you have an oxygen and it is attached like that, so that is an ether. Okay, that is very important for us to understand. And then we've got these 3 A's. Hope you might never forget. So these ones we're talking about, your alkyl halides. Okay, your alkyl halides. Okay, so in the previous one we're talking about acyl halides. Okay, this one we said is an acyl halide. This one was saying it's an alkyl halide. Okay, so for the acyl halide, we said you're going to have a CO attached to some group 7 element, or it can be fluorine, it can be chlorine, it can be bromine, it can be iodine. However, when we're talking about alkyl halides, these ones are a bit different. You're just going to have maybe it's, your chlorine is just being attached to a certain group. You can have you can have chlorine, you can have bromine, you can have iodine, you can also have fluorine. Okay, these ones are just going to be attached like that. So that is the first A in the last in the last presentation of the mnemonic. Okay, now what about the other last two A's? This one we're talking about alkenes. Okay, we say these ones have got a double bond, so it can be something like that. Okay, which we are going to talk about. So basically those are the alkenes. Then alkynes are the last ones in the on this list. So alkynes, we said they've got a triple bond. Okay, so basically these are some of the functional groups that you are supposed to understand. Okay, of course you're going to have some special groups. So some of the special groups that you're going to have, if let me say I've got this and that, then I've got an arachane. This is called an isopropyl. Okay, then I can have another case. Let me say this like that. Okay, excuse me for that. These are special groups. Then I've got an ara. This is called sec butyl or butyl. That is very, very important for us to understand. Then other special groups that you can have. If let me say this, that, another one, then let's say there's an ara here. Okay, so this is called an iso. You're able to say that you have got an iso. Now because you've added another carbon there, you're going to have an isobutyl. Okay, you're going to see where some of these names come from. But since I've said these ones are special, you might want to also know them. They might want to focus on them in the exam. Okay, now you can have also this compound. Now if it is like that and you have an arachane this side, this even just you're able to say it because it's in a 4-star shaped, this is going to be called tet-butyl. Okay, that is very, very important for us to understand. Then let's say the same diagram. Okay, now in this case, instead of putting an ara there, let me now branch off and put another ara. Okay, this will be called a neopentyl. Okay, so basically these are some of the things that you're supposed to understand, and it is very, very important that we understand these concepts. Okay, now that we've talked about these organic compounds, how they're coming about, now let's talk about almost each one of them in a bit detail. But before we talk about those ones, what are some of the general properties that you're supposed to understand? Okay, you have to understand that these organic compounds, they are insoluble in water. Okay, so because they are insoluble in water, what are you supposed to understand? What that translates is that they do not dissolve in water. Okay, so what is the next point? The next point will be that these ones are going to be soluble. They're going to be soluble in organic solvents. Okay, so they'll be in organic solvents. So examples of solvents, we're talking about benzene, we're talking about solvents like paraffin. Yes, they will be very, very much soluble in those ones, but when it comes to water, they do not. Then these organic compounds do not conduct electricity. They are not good conductors of electricity. Okay, and then the other thing that you're supposed to understand is that these organic compounds, they have a very low melting point. Okay, So what does this mean? It means that at a very small temperature they just easily melt. Okay, then you're supposed to understand that also that these organic molecules, they are volatile. Now volatile to mean that they can easily evaporate, and that is also one of the properties that you might want to consider. Then these organic compounds are highly flammable. They are very flammable. What that means is that they can easily catch fire. So the more you know about something, or the more you know about these organic compounds, the better on how you're going to be using them. Then earlier we talked about, in organic chemistry we're also going to be talking about hydrocarbons. Now here that's what we're going to talk about: alkenes, alkanes, and alkynes. So what are hydrocarbons in this case? So you're going to have hydrocarbons that only have a single bond. Okay, you're going to have hydrocarbons that are going to have a double bond, and you're going to have hydrocarbons that have a triple bond. So basically this is very important. So a hydrocarbon that is going to have only single bonds. Okay, so these single bonds are just between carbon and carbon. Okay, so in this case, if I've got C to C, okay, we only have a single bond there. Even if I put also other ones, they're just single bonds throughout. These ones are called alkanes. Okay, alkanes. So about alkanes, what are you supposed to know and understand? These alkanes, we've said they have single bond. That is very, very important. Then what you should understand is that the general formula for alkanes, which we are going to talk about in detail. Okay, maybe in form of a diagram, it can be better. Then a double bond, when we talk about the double bond itself, what are you supposed to understand? If I've got, this is a chain of carbon and another carbon, and there's a double bond between them, this one is called an alkene. Okay, alkenes, and that is very important for us to understand. Then lastly, we have, when you have a triple bond, okay, these ones are called alkynes or alkynes. So basically this is very, very important for us to understand. Now what would be the general formula for some of these compounds? Okay, so if I'm going to break my graph into like that, or my title into like something like that, let me just use a nice illustration. If I'm going to cut it like this and draw it like that, just to make it very much visible. So if that is what we have, so when we're talking about alkanes, these ones are saturated hydrocarbons. Okay, those will be alkanes. These ones, the alkenes, will be unsaturated, and mostly are going to be talking about alkanes and alkenes, and you have to be very, very confident about these ones. Now saturated for alkanes to mean that the carbons are complete. Okay, there is no double bond, and the carbons are very complete with the hydrogens. Okay, nothing is left out, and that is how you're going to identify alkanes. They have a general formula of CN H2N plus A2. Okay, so they end in ANE. Okay, those ones will be alkanes. Okay, and that is very, very important for us to understand. Okay, now that we've talked about that, let me just now make it a bit interesting. let's now talk about alkanes. So now that you've identified that this is a saturated compound, it only has a single bond and it has a general formula of CnH2n plus 2. These ones, we are saying these ones are alkanes. Okay, so if they are alkanes and they've got those properties, you've identified that the name ends in A and E. Now you name the alkanes based on the number of carbon atoms that are present. Okay, so if the number of carbons, let me say these are carbons, okay, number of carbons, then what is going to be the prefix? This is very, very important. Okay, if I've got only one carbon, this is going to be called, or the prefix is going to be meth. Okay, if I've got two carbons only, this is going to be eth. Okay, if I've got three, this is going to be prop. Okay, if I've got four, this is going to be, you're going to have a but. If I've got five, you're going to have pent. If I've got six will be called hex. Okay, basically, then what about 7? 7 is going to be called a hept in terms of the prefix. Then let's say if we've got 8 is going to be called oct. Let's say we've got 9 is going to be called non. Okay, then if you've got 10 is going to be called a dec. Okay, can be dekin, decine, decan. Okay, so an alkane with only one carbon. Therefore, if we're talking about alkanes, an alkane with one carbon, it is going to be called what? Methane. Okay, basically that is a basic principle that I'm trying to drive across. So now what would be the formula for this methane? So based on our formula, we said our general formula is CnH2n plus a 2. Okay, so in this case, since we are saying meth is 1, meaning the n in this case, the number of carbon atoms is 1. Okay, therefore I'm going to have C1 H2. I'm going to put the 1 wherever there is n. This is what I have. If I simplify, I'm not going to put the 1 because it's just the same. I'm going to have H 2 multiplied by 1. In this case, I'm just getting a 2. Then I have a plus 2. Then what am I going to have finally? I'm going to have CH4. So basically, this will be the structure for methane. Okay, another example that we can give is, what if I have butane? What is its structure? So the same formula, Cn H2n plus 2. Okay, in this case we're talking about butane. Now butane, we said but just means 4. So in this case we're going to have C4 H 2 multiplied by 4, that is 8 plus a 2. Therefore this simplifies to C4 H10. Okay, that will be butane. Okay, and that is very, very important for us to understand. What about propane? Okay, prop, so we're going to say Cn H2n plus a 2. So in this case, what are we now going to have? Prop means 3, so we're going to have C3 H 2 multiplied by 3, that is a 6. A 6 plus 2, that is an 8. So basically this is the structure for the propane. Okay, and that is very, very important for us to understand. Now, one thing that you should understand is that in this nomenclature, alkanes, if I'm going to just represent alkanes, okay, you know that carbon always makes 4 bonds, so that would be like an alkane. Now, an alkane itself undergoes, because carbon makes 4 bonds and all of them are complete. In this case, this one is going to be in terms of hybridization. Okay, and the hybridization is just making hybrid orbitals. So in terms of hybridization, these are going to be sp3 hybridized. If I'm going to just draw a diagram like that, and everything, this is going to be sp3 hybridized. Okay, then on unsaturated or alkenes, basically we've said they've got a double bond. Let's say this is our C and there's a double bond there. Carbon makes at least tries to make 4 bonds. So this, if I'm going to get this one, what would be the hybridization? This is how many electron regions or domains do we have for the carbon that we are, it's of our interest. So we've got 1, 2 and 3. Because there are 3, this is going to be sp2 hybridized. Then lastly, if you've got an alkane, if they say this is the thing, how many electron domains are you going to have? So we've got 1 and 2. So for this one, that is on the middle. So because there are 2 in that case, I'm just going to have sp hybridization. Then the general formula is just to make them stick to us. So alkanes themselves, they've got the general formula of Cn H2n plus a 2. However, when you come to alkenes, for alkenes it's only Cn H2n. Okay, this 2 is not there. Okay, however, when you come to alkynes, it's not very much different, but it's the same concept. I'm going to have Hn2n. Okay, so the only part here is, the only part that differs is, look at this one as a positive 2. Okay, this one the 2 has been removed. This one we're going to have a minus 2. That is for alkynes, and that is also very important for us to understand. Okay, now how do you represent these compounds? Okay, so you can use the general formula, of course. However, you can also use formulas that are very, very different. You're talking about molecular formula, empirical formulas. Those are very, very vital, and they're very important if we were to understand. So what are some of the type of the formulas that you are supposed to understand? We're talking about things like a molecular formula for a compound. Excuse. So that the molecular formula just represents the the actual number of atoms in a molecule. For example, let me say I've got glucose. Glucose, you know that glucose is C6H12O6. That is glucose. So that is its actual formula. Okay. Then you also have to understand what we call empirical formulas. Now, empirical formulas, we're talking about the simplest ratio of atoms that are present, and this should be a whole number. Okay, so what do I mean? So that this is what we have. If we're going to simplify that, it means we're going to divide throughout. If you want, we can divide throughout by 6. If I divide throughout by 6, I'm going to have CH2O. Okay, that is the empirical formula, the simplest whole number ratio. Then you can also have a dash formula. Okay, dash formula. Okay, which is quite what we usually use. If I've got a compound, then I'm just going to show dashes where the hydrogens are going to be. So basically that will be like our dash formula. I'm just showing dashes. Okay, and that is very, very important for us to understand. Then what other thing are you supposed to also know on this topic? You also have to understand a condensed formula. So it is condensed for the fact that let's say we have a dash formula where we have, let me say I have C. Let's say I have C here. Okay, let me try to come up with a molecule. Let me say I've got, there's H, there's H, there's another H, and let's say we have another C. Okay, let me just represent it nicely. Let's say we have a C, a hydrogen, and a hydrogen, and this molecule of ours is going like that. Okay, and let's say here we have another group where we have C, and this C we have an H on top, we have an H here, and we have an H there. Then let's come to the other one. Let's say here there is a double bond. So here I'm going to put an H. Carbon always make 4 bonds. Okay, to attain stability. I can put H here, I can put H here. Okay, basically let's say this is what I have. Instead here, let me just also put another H. So if that is what you have as the dash formula, or let me just say the structure formula for this compound, also called the Kekule structure. Now in this case, what are we going to have? You're able to see that this is the first carbon. How many hydrogens is it attached to? So you're going to say CH. How many hydrogens? 3 hydrogens. Okay, I'm going to put a dash. Now I come to the next carbon. I'm going to put my carbon. However, this carbon, how many things is it attached to? If you're going to see on top here, there is a methyl, okay, a CH3. So therefore, I'm going to put a dash here, and I'm going to put CH3, okay, on top. Then going to the other side, there's a double bond. I'm going to put a double bond. Then there's this, C hydrogen or carbon, and it's attached to hydrogen. So I'm going to put CH. Then I'm going to put a dash again. There is a C here which is attached to 3 hydrogens, so I'm going to put CH3. This is a condensed formula. Okay. Then you're also supposed to know what the skeletal formula is. So about a skeletal formula, in this case, you can show everything, but you are just not showing your hydrogens. So I can have a structure that they've just drawn like that. This is a very valid structure, but the hydrogens doesn't mean that they're not there. You just chose to ignore them, but they're there. But this is mostly because sometimes it's very tedious to be writing all the hydrogen atoms for very, very big compounds. So basically, you might choose to do justice based on what they usually use. Then what you should understand is that you also have to understand something that is very critical. Let me say I have a compound. If this is a compound, okay, let me put points here. This point, there's a point here, there's a point here, there's a point, and there's a point. Okay, let me put something else. Let me put also here and there. Okay, now this is an organic compound. Now what you should understand is that you have to name and label them. We've said about the IUPAC. So this is 1, 2, 3, let's say 4. Okay, now this is the skeletal structure. Now if this is a skeletal structure, the hydrogen that is attached to this carbon, it is called a primary. Okay, a primary hydrogen. And this carbon is called a primary carbon. Okay, then let's come to the second one. This is the second carbon. The second carbon is attached to this first and the other carbon. Okay, this one is going to be called a secondary carbon. Okay, then we have this other one here. What is it going to be called? How many things is it attached to? Okay, let me just make it interesting. Let's say here I have another constituent like that. So in this case, what is it going to be? Because it's attached to this group, it's attached to this and that. Okay, this is going to be called a tertiary. Okay, a tertiary. Then we have another one here. Now this one is attached to four things: this, and that. So this one is going to be called a quaternary carbon. Okay. Okay, quaternary carbon, and that is very, very important for us to, understand. Now that we've understood that, there's another concept that you're supposed to understand. If, let me say, this is our skeletal structure, then I've got a double bond here. Okay, you're going to have different kinds of carbons here. So you know that this one that is here, it is a primary carbon, right? However, this carbon, since this is not just a straight chain, you have a double bond. Double bonds usually bring kinks. So what you're going to have now, in this case, if that is carbon, this is another carbon, this is another carbon, and that is another carbon. Okay, now this carbon is attached to a carbon that is attached to a double bond. Okay, this carbon is going to be called an allylic carbon. Allylic carbon. Then we've got this carbon which is directly attached to the double bond. This or this other one, these two, they'll be called virylic carbons. Virylic. Okay, virylic carbons. Other literature, they're going to refer them as vinylic. Okay, vinylic. So that is very important for us to also understand. Okay, now that we've talked about some of the key concepts and about these hydrocarbons, let's now move on to other things that we might want to consider. How we name these compounds. Okay, so it's a bit interesting how you name these compounds. Basically, you're going to use the same principles that we've talked about. Okay, so the principles that we've talked about, in the case of the alkanes, let's start from there. I think so. When I'm naming these compounds, mostly we're going to be talking about structural isomers. Okay, so what do I mean? So if I've got C4H10, if this is just a structure, this doesn't tell us exactly how the atoms are attached in this molecule. So what are some of the possible structures that you're going to have just from this same molecule? Since we're saying this is C, okay, C like that, and you put your hydrogens, all of them, 1, 2, 3, 4, 5, 6, 7. Am I counting right? Hope so. Okay, there should be 10. Okay, So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, according to the formula, they should be 10, and we are correct. Basically, this can be one of the possible structures. However, you can have another structure that it can be C, C, C. Okay, 4 of them. Or let me say I've got 3 of them. Okay, these 3 of them, I can put a carbon also here. I can put it like that. And I've now put my hydrogens throughout. Now if I put my hydrogens throughout, what you're going to notice is that it is the same structure with the same name, but you're able to see that the way the atoms are attached is very different. So that's why I've emphasized we're going to be talking about isomers. Now we know that isomers, these ones, they've got the same number of atoms, but the arrangement of the atoms is different, and that is very important for us to understand. Okay, and what are some of the things that we're now supposed to now, dive deep into how you name. Okay, now nomenclature is very, very key when we're talking about electrochemistry or organic chemistry. So you can't afford to not know nomenclature. Now the prefixes that we used are very, very vital if we are going to understand this. We've said if we're dealing with one carbon, we're talking about meth. If you're talking about 2, we're going to be talking about eth. If we're talking about 3, we're going to be talking about prop. If we're talking about 4, we're going to be talking about but. If we're talking about 5, we're talking about pent. If we're talking about 6, we're talking about hex. Okay, if we're talking about 7, this will be hept. If we're talking about oct, we're talking about 8. If we're talking about nona or non, this would be 9. If you're talking about 10, this would be called deck. So if I'm going to put the numbers, this is 1, 2, 3, 4, 5, 6, this is 7, 8, 9, 10. Basically, this is the number of the number of carbons, and the prefix that before it. Okay, and that is very, very important for us to understand. Okay, now let's solve some questions and how you're going to be naming them. So let's say we have a compound. Okay, if that is our compound, how many carbons? 1, 2, 3, 4. Okay, so, and that is the longest chain, so you always consider the longest chain. So what are we going to do? So I'm able to say that this is just that there is no double bond that is attached to anything. So, and it has 4 carbons, so this will be called butane. Let's write another one. What if we say we have this 1, 2, 3 like that? So what is it going to be? We have to count the number of carbons. So we got 1, 2, 3, 4, 5. Any double bond, there is no double bond, so this is called pentane. Okay, that is very important for us to understand. What if I've got this? Okay, what is it going to be called? Now we have a double bond. We have a double bond here. Okay, so because of a double bond, how many carbons do we have? Okay, so we have 1, 2, 3, and 4. Now what you should understand is that we have to consider the position where we have the double bond. Okay, so in this case you have to make sure that in as much as you're numbering, make sure that you meet your substituents as early as possible. Another approach someone can take in terms of numbering, they can call this one as 1, 2, 3, and 4. On position number 3, that's where I'm meeting the substituent. That would be a very long way to take. But if you're just starting from 1, and that's where you're going to find the group, or let me say the double bond in this case, you're going to have what you're going to have now is you're going to meet your double bond early. So in this case, what is it going to have? What is it going to be called? It's going to be called 1-butene, 1-butene, because there's a double bond. Okay. If you want, you can start with but. So this will be but. Then on position number 1, we have a double bond. Okay. In this case, it is going to be called but1 in. Okay, and that is very, very important. The 1 in this case to show the position. Okay, position of the double bond. Basically, that is it. Then let's say we have another one. Let's say this is. Let's put a double bond there. Okay. Now, like we've said, we're always starting from the direction where the double bond is going to be found on a smaller number. Okay. So in this case, we can choose to go into the 2 directions. We can choose from here 1, 2, 3, 4, and 5 as a parent chain. Okay. So when we're starting from 1, we're meeting the closest as our double bond at position number 2. Now you can, if you start from here 1, 2, 3, you're about to start a meeting at 3, so we're not going to use that approach. So we're going to maintain the same one: 1, 2, 3, 4, and 5. Okay. So because it is 5, what is the parent name? The parent name, you know that this is a pentene. But what name now do they overall want? So we have to look at where we find the double bond. Okay, in this case it's on position number 2. So this can be called 2-pentene. Okay, because on position number 2, that's where we are finding a double bond. Or you can say pent 2 1 or 2 in actually. Pent 2 in. Okay, basically this is how you're going to show that. Let's have another one just to familiarize ourselves with the concept. What if I've got this? Okay, if I've got this, so in this case, what I'm going to do, so if we're going to now name them, this is 1, 2, 3, 4, 5, 6. However, let's also try the opposite. The opposite, what I'm going to do, this is 1, 2, 3. Okay, so in both, we're going to be meeting. So in this case, for this one, it doesn't matter the direction you are taking, okay, because the triple bond is all on 3. So in this case, how are we going to name this one? So you can start with the substituent. You can start at which position? This is 3-heptine, heptine, 3-heptine. Okay, or it can be also called hept. Okay, hept on position number 3. That's where we have our triple bond. So it is 3. Okay, and this is an alkane. So it is going to end in Y-N-E. That will be our answer for this one. So basically, that is very, very important for us to understand. Now, what if you say now we have, some inside groups? Okay, so what are we now going to have? Let's say we have this. If that is what we have, then we have a group here. So what is going to be the name for this compound. So always name your parent chain. So if you said 1 2 3 4 5, and if you also try to use the opposite, this is 1 2 3. So we're finding this substituent at position number 3. So whether you're going in the direction, you're still going to get the same answer. Okay, so now what do we have? You're able to see that on 3 we have a methyl. So we're going to say 3 methyl. Now methyl what is this? This is an alkane. So methyl, and how many carbons is 5. The parent name, we know that because it's 5, it's supposed to be pentane. Okay, so even in this case it will be 3 methyl pentane. Okay, so that is very important for us to know. Let's have another example. Let's say this is our diagram that we have. So what is going to be the name for this compound? Okay, so basically you have to consider again which one is the longest chain and where are you meeting your substituents faster. So basically if you start from the 1 2 3 4 5 and 6, okay, so basically that would be the longest chain. Okay, now if that is the longest chain, what are we now further going to have? Okay, now you're able to see that this is an ethyl, this is a methyl. Okay, so now what are you now going to do? So we're going to name them based between E and meth. Okay, E comes earlier than the meth. Okay, so in this case, since E comes early, so we're going to start with the E. Okay, based on we're going to follow the alphabetical order. So now on E, or let me say the ethyl is on position number 3. So I'm going to say 3 ethyl. Okay, ethyl. Then we have another concentration position number 2. So I'm going to put a dash or a hyphen. 2 on position number 2. What do we have? We have a methyl. What is this whole compound? You able to see that there's no double bond. This is an alkane. But now how many carbons? We have 6 of them. So this is going to be called methyl hexane. Okay, so it's going to be called 3-ethyl 2-methyl hexane. So that is very, very important for us to understand. Okay, let's say now we have multiple in a similar manner. Whatever we've talked about, this is in a similar manner. That's how we're going to get the names of alkanes, alkynes with a lot of substituents. Okay, maybe also let's solve some questions again. Let's say you have this, and let's say you put something like that. So what are we going to have? We said you name based where you're able to meet your substituents faster. So in this case, we're going to have 1 2 3 4 and 5. Okay, now what do we have as? So we have a methyl here. So in this case, we're going to have 2. Our answer is going to be 2 methyl. Okay, now what kind of a molecule is this one in terms of hydrocarbons? So you're able to say it has 5 carbon atoms, so it's going to be called a pent. Okay, pent. Now pent. Then on where is the double bond? The double bond is on position number 2. So I'm going to say pent 2 in. Okay, so that is very, very important to us to understand. Okay, let's solve another one. Let's say you have this. Okay, let's put double bonds there. Now if we put double bonds, what do we have? So where we're meeting the chain earlier, that's what you are going to indicate. So we have 1, 2, 3, 4, 5, 6 and 7. Okay, so now what are we going to now have? So what kind of a molecule? 7, you know that is hept, so I can say hept. Okay, then you're able to see that on position number 2 we have a double bond. On position number 4 we also have a double bond. So in this case, this is just going to be a because the parent name will be heptene. Heptene is an alkene. So in this case, I'm going to have hept 2. We have a double bond. So again, we have another one on position number 4. So 2, 4. This is going to be called diene at the end. So hept 2, 4 diene. Okay, because we have 2 double bonds. And that is very, very important for us to understand. So what do we now do? We can also now what can we talk about now? I think we've talked about much of the things. We can now transition to alcohols. Now we're going to talk about alcohols, ketones, aldehydes and ethers, and how you basically name them. So let's start with the alcohols. So alcohols, you know that the functional groups for alcohols, you have a chain there and you have an OH. Basically that is the functional group. That's what gives its characteristics. So let's solve some examples and let's name them. So let me say I have this and I've got an OH. So we said you name them based on priority. Now you can't write this is a carbon. No, that's where you're touching your OH. Okay, so that's where the reaction happened from, and you have an OH there, so there's no carbon there. So in this case, you can start from here 1, 2 and 3. However, at 3 that's where you're going to have the OH, or the opposite. You're going to start at 1, 2 and 3. So we're going to go with this one because the 1 is just very close to the OH group. So basically, what is going to be the name for this one? So you know that because we're saying there's 3 carbons, so this one initially is going to be called propane. Okay, propane. That is what it's supposed to be. However, the parent chain, we have like on position number 1, we have an OH. Okay, so in this case, now our final name is going to be propan. Then on position number 1 we have an alcohol. So in this case we have an OH, so it's going to be propan 1O. Okay, so that is how we are going to solve it. So let's solve another one. Let's say you have if this is our compound, we have an OH there. How are you going to name our compound? So you can take either route, right? So I can take 1, 2, 3. Okay, this will still be position number 2. Okay, so basically what are we going to have as the name? Since it also has 3, it's going to be called propan. On position number 2, that's where I have the OH. So there, that's where we're going to put a hyphen and another hyphen 2O. Okay, because this is an alcohol. What if now you have 2 or more alcohols? What are you going to do? Okay, what are we going to do? Let's say you have HO, okay. So basically this is what we have. Now what you should understand is that, so this would be 1 or this would be 2 or the opposite. But at the end of the day, whatever you're going to name it, but you have to follow that if I put a 1, still OH would be prioritized. If I also put a 1 here, OH will still be, you know, prioritized. So in this case it doesn't matter. But what does matter in this case, because this one has got 3, so it's going to be, you know, that the name is ethane, okay. But now ethane, so I'm going to have eth, okay. Instead of me just having ethane, in this case I'm going to also put the E. Why I'm putting the E is that we don't remove the E at the end because we have 2 hydroxides, okay, 2 hydroxide. So in this case I'm going to have ethane. Now position number 1 and position number 2, that's where we have our hydroxides. So in this case I'm going to put 1, 2, this is di-O, okay, because it's an alcohol. So basically that is very important for us to understand. Okay, so let's have another one. Let's say we've got that. Okay, if this is what we have, let's say we have a double bond there, and okay, we can put an OH here, we can put a chlorine here, and we can, let's say we can also put a hydroxide there. So what are we going to have for this one? Okay, this is quite interesting. So how are we going to name? So in this case we have an alcohol, we have an alcohol even there, and we also have a chlorine, okay. So in this case what are we going to do? So we're going to prioritize an alkene, okay. So because alkenes are the ones that are mostly prioritized on that list compared to alcohols. So in this case an alkene has higher priority than halogens. That is very important. Also halogens like chlorine, like that. So basically our name should be something that is very you know, interesting. So in this case let's start with the substituents. So we've got that. So if we're going to name our compound, so I'm going to start 1, 2. So we've prioritized the double bond. So in this case we got 1, 2, 3, 4. Okay, the other ones are just for connecting. So if that is what we have, so we're able to see that on position number 4 and on position number 1. So in this case what am I going to have? I'm going to have 4 chloro for the chlorine that we have. Now that is a butane because there are 4 carbon, you know, atoms. So in this case I'm going to have 4 chloro but, okay. Then on position number 1 we have a double bond, so I'm going to say but 1 in. However, we still have other things. We still have our hydroxides. So in this case I'm going to put on position number 1 we have a hydroxide, comma, on position number 4 we also have hydroxide. So in this case this is going to be di-O, okay, the alcohol. So basically that is how you're going to, you know, name, you know, this compound. Let's solve, another one. So let's say you've got this structure. Okay, so how are you going to name this one? Now this is a hydroxide, this is a methyl, and this is the double bond that we have. So now that the hydroxide, in this case, an alcohol has higher priority than a double bond. So in this case, what are we going to have? We have to first name our, we have to number our. So basically this side is just a substituent and this side is a substituent. Okay, so what do we have? So basically, let me what do I do? Okay, let me not put the, let me just put it like that. Okay, I think this will make sense. So now if I put it like that, this will be position number 1, this will be position number 2. Okay, why we've put 1 there? Because the alcohol has higher priority than an alkene. Okay, so basically that is what we have. So now if we solve this, what are we going to have? Since this only has 2, okay, 2 3, actually, like that, 2 3. So because it has 3, in this case it's going to be called propane, so this will be prop. On position number 2 we have a double bond, so I'm going to say prop 2 in. Okay, now on position number 1 I've got an alcohol, so I'm going to say 1 O. Okay, basically that is what I'm going to have. Let's solve another one. Let's say I've got this, let's say like that. Okay, something like this. Let me also put maybe a double bond there. So what are we going to have? Always name the parent chain, but in this case what will be our priority? Hydroxide still has the priority, so in this case what do we have? I'm going to name them as 1, this is 2, this is 3, 4, 5, 5, let's say 6, that will be 7. Okay, so you can choose the other. If you want, you can put it on the other side on top here or not, or you choose the other one where we've put here. So basically this is what we have as our longest chain. Okay, because it's 7, that just means hept. Okay, so in this case let's now start naming the constituents. Now you're able to see that there on position number 6 we have the methyl, so I'm going to start from there. So I'm going to have 6 methyl hept. Okay, hept. Then if we go to position number 6, the same position number 6, that's where our double bond is. So in this case on position number 6 we have a double bond which is En. However, if we also look at position number 2, here we have an alcohol. Okay, so for me to I'm going to also put another dash and another dash to now represent the alcohol, which is OL. Okay, basically that is how we are going to go about that one. Let's solve another one. Let's say you have this, you have, let's say, NH2, you have an OH. So how are we going to solve that one? So in this case we have an amine, and a hydroxide. A hydroxide has higher priority than an amine. An alcohol has a higher priority. So in this case this will be 1, 2, 3, 4, 5. Basically I didn't start from this side because I want to make the one with the highest priority phase, which is the hydroxide. Now that I've got this, what is the name for this compound? Since it has 5, it is going to be called pent something. Okay, pent something. So let's start. Now, since we are prioritizing the alcohol, we should end. So we are going to start with the constituents. On position number 4, we have this amine. Okay, so I'm going to have 4 amino pentane. I'm supposed to write pentane, but I'm going to say pentane. Okay, pentane. Then on position number 2, that's where we have our hydroxide on the other side. So it will be pentane 2O. Okay, so basically that is what we have. So let's solve another one. What if you got this? Okay, you can also put like that, and we can also even put an OH here. So what is this compound going to be called? So name put your numberings. If I start from here 1 2 and I start going like that, I'll meet the hydroxide late. So in this case I can even put the one where the hydroxide is. So I'm going to say 1. I can go now in any direction. 1 2 3 4 5 6. Okay, so it's 6. So what are we now going to now have? Okay, so in this case, let's start with our methyls. So we're able to see that on position number 2 we have a methyl. So I'm going to say 2 comma. On position number 5 we've got 2 methyls, this one and that one. So I'm going to say 5 comma 5. Since there are 3 methyls, so it will be 2 comma 5 comma 5 try. Okay, you have to put it there, try methyl. Okay, methyl. Then what do we have overall? You're able to see that this is cyclo in nature. So in this case, it is going to be called cyclohexano. Okay, hexano, because it's an alcohol like that. So there's no need of putting the position of the hydroxide because we started from there. So why writing the 1? So that is very, very important for us to know. Then let's talk about now how you solve for aldehyde and ketones. Now, like we said, the difference between these two is not very, very big. So if let's say aldehyde, an aldehyde in this case, you're going to have an R group that is attached to a carbon, okay, and the hydrogen, and we have a carbonyl group on top. This group is what we are calling the aldehyde in this case. Now, a ketone on the other hand, you're talking about a carbonyl that is surrounded to these 2 R groups. Then you have a carbonyl on top. Okay, it's just that when naming these aldehydes and them being found at the end of the chain, they're different, but the formula might be. It's just that the other one, ketones, are going to be found inside the formula. Okay, but these ones are going to be found away from the formula or at the end of the formula. So basically that is the thing. However, when you're naming the aldehydes, the name should end in AL, and we mentioned that AL. When naming ketones, the name should end in 1 or ONE, like we earlier said. So basically this is very, very important for us to also consider. So let's solve some questions to familiarize ourselves with this concept. So let's start with okay, let's start with ketones, or we can be jumbling, whichever way. Okay, so ketones. So what can I come up with? Let me say just the general one, the one just from where the formula is. Let's say this is that and that is that. Okay, so we're going to name our carbons. So this will be carbon 1, this will be carbon 2, this will be carbon 3. Either way, the position where you have your bond there, or your carbonyl, is at 2. So because there are 3 carbons, the parent name is as propane, but in this case it's going to be propan. Okay, propan. Now on position number 2, that's where I have a ketone. So I'm going to say 2, 1. Okay, propan 2, 1. Okay, and that is very important for us to know. Or this is what we're calling propanone, because it's the simplest that you're going to have. Okay, what if you mix ketones with other compounds? Let me say you have got this, and let's say you have a chlorine there. Let's say you have the ketone here. Okay, so now how are we going to do? Name the parent chain, number it. But now, which one comes first, the ketone or the chlorine, or which we said this is an halide? Okay. Now, if it's a halide, in this case, it is in less priority. So priority is given to the ketone. So why are we considering this priority? Because the way you're going to name your compound is going to be different, and if you use the wrong parameters, you are going to get the wrong answer. So let's say you start from here, 1, 2, 3. Basically this, it means you've prioritized the halogen. However, the one that is supposed to be prioritized is the ketone. So in this case, you're going to have 1, 2, 3, 4, 5, 6, and 7. So because it's 7, this is going to be hep10. Okay, now hep10, not really hep10, because we also have other subsequents. So this is just the parent name, okay, where we can that will help us. So let's start. On position number 5, we have a chlorine. So I'm going to say 5 chloro. Okay, chloro hept. So I'm going to put hept. Now that I've put hept, what other thing is going to follow? I'm going to say heptan. Now heptan, then able to see that on position number 3, I also have, that's where the ketone is. So I'm going to say 3 heptan, 3, 1, like that. So this is going to be 5 chloroheptan 3, 1. Okay, so that is very, very important for us to also understand. Now that I've talked about aldehydes, what about how are you going to be naming your, now that I've talked about ketones, how are you going to be naming your aldehydes? So let's give an example. Let's say we got this compound. So if we're going to name our compound, so if this is our compound, now which one is going to be given priority? Because the way we number, we said we number based on priority. Okay, so you know that the aldehyde is usually found at the end, right? This is the aldehyde. Then the ketone is going to be found inside the molecule in terms of the carbonyl. So which between the two, the aldehyde or the ketone, is going to be prioritized? you know that the aldehyde is prioritized, given priority. So in this case, I'm going to have 1, I'm going to have 2, 3, 4, and 5. So because it's 5, the parent name in this case is going to be pentane. Okay, pentane. But now, based on the molecule that we have, what is now going to be the overall? So we're able to see that what we are now going to have is that aldehyde and ketones, when they're combined like this, it's going to be called oxo. Okay, but now oxo for the ketone to mean, so on position number 4, so this will be 4 oxo. Okay, this is a pentane, so it's going to be pentane. But now, because we've given priority to the aldehyde, so this is going to be pentanal. Okay, pentanal. Basically, this is what you are going to have. Okay, now let's solve another example. Let's say you have let's say like this. And let's put our chlorine there. We can put another one here. Let's put our OH here. We can also put another one here. Let's put a carbonyl there. Okay, so because of this is the aldehyde, this is a chlorine, a halogen, and we have an alcohol there and another ketone there. Now this is a very, very big molecule. So basically, how are you going to, you know that because of the aldehyde, we're going to consider it first. Okay, it will be the priority. Because it's priority, I'm going to say this is 1, this is 2, this is 3, okay, this is 4, this is 5. Okay, because it's 5, our parent name will be what? Pentane. Okay, because it's pentane, but now, like we said, let's now name the subsequents. On position number 2, we have a chlorine, so I'm going to say 2 chloro. Okay, then which other position? On position number 3 now, we have an alcohol, so I'm going to say 3 hydroxy. Because that's the hydroxide, so this will be hydroxy. Okay, because I've said hydroxy because it is a group. Okay, a group in this case that is not prioritized for this case. Okay, then on position number 4, you're able to see that we have a ketone there. So on position number 4, so this, it is going to be 4. Now, because we have a ketone and an aldehyde, so this will be called 4-oxo. So this will be oxo. Now that's when you now put your pentane. But now, because this is an aldehyde, and you said we are giving priority to the aldehyde, so it will be pentanal. So basically, that is going to be our answer for this one. Let's solve another one. Let's say you have this compound. Okay, and let's say you have O there and you have another O there. Okay. Now the basic question that I can ask you now is this carbon giving us a ketone on an aldehyde? Now you're able to see that this is a very close structure, so you only found aldehydes are only found at the end of a chain. But now this is a cyclic, so we don't have an aldehyde here. We only have ketones. So you're able to see now you're just supposed to name your compound nicely. So mostly for a cyclic structure like this, just start where the constraint group is. So I'm going to start 1, so I can name them. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now that I've got this, what am I now going to have? So you're able to see now that on position number 1 and on position number 4, we've got these these ketones. So in this case, what are we now going to have? So I'm going to have one also on position number 4, 1, 4. This is a cyclic structure, so this will be cyclo, and this is a 6 carbon. They are not double bonds in terms of the ring structure inside. So this is going to be called hexane. It was supposed to be hexane, but now because we've got two ketones, in this case we're going to treat it like the way we treated it from the hydroxide. We're going to also put an E there. We're going to maintain it the way it is. Now this will be di. Why we're putting di? Because we've got two ketones, this one and this one. Okay, that's where we're finding, that's the position 1, 4, di 1 or di on. So that is what we are going to have. Okay, basically now how do we name ethers? Okay, so an ether, the way it is, you have an oxygen, then you've got two R groups at the far end like that. So let's have some examples. So let's say this is our structure that we have, and let's say maybe we put it like that. Let's put a double bond here, let's put an oxygen there, and like that let's put a chlorine here. So overall, what are we now going to have? So you have to make sure that which one are we giving priority. There's an aldehyde here. Okay, actually that is a ketone, so I'm going to let me put it like that, so that we make this one is an aldehyde. Okay, we have an ether here and we have a chlorine there. So basically you always give, in this case we're going to give the aldehyde the priority. Okay, so because we've given it the priority, the naming also matters. So we're going to start from where it is. So this will be 1, this will be 2, 3 and 4. Okay, because it is 4, and what kind of a molecule is it? So this will be butane, that will be the parent name. But what is the actual name for this now formula? Okay, or for this compound. So we're able to see that on position number 4, name the constituents first. So I'm going to have 4, this will be 4 chloro. On position number 4 we have a chlorine, so this will be 4 chloro. Then on position number 3 you're able to see that's where you have your ether. Okay, so in this case we're going to have 3. Now there is like a methyl on the other side. So in this case a methyl has reacted with the oxygen, so that will be called the methoxy. Now that's when now you write now the actual name for the compound, butane. But now because this is an aldehyde, so instead of me writing butane, I'm going to write butanol. Okay, basically that is what you are going to have. Let's solve another one. Okay, so if this is our compound and this is an ether, so every time we're naming an ether, you've now realized that we consider two groups. Okay, so in this case, like in our case, we've got this group and we've got that group. Okay, this group, which is the bigger group, we can also name it. So this will be 1, this will be 2. This group, the other one is just going to have 1 like that. Now if this is what we have, you always start with the smaller group. Okay, now what you should understand is that what do we have? Always start with the smaller group. So the smaller group, name it, then you go to the bigger group. So if you name the smaller group, what we have on the smaller group, we have a methyl which is attached to oxygen. So in this case, this would be methyl, okay, methoxy, okay, ethane. This is the ethane on the other side, okay. So basically, this is how we are going to name this compound. Maybe to familiarize ourselves more with this concept, let's solve another one. Let's say you have this ether. Okay, so basically this side I've got an ethyl group, and this side I also have an ethyl group, okay, and there's an ether there. So in this case, this is going to be ethoxy, okay, ethoxy ether or ethane, because this is ethane, it has 2 carbons and the other one has 2 carbons as well. So that is very important for us to understand. Now let's solve another one. Let's say this is what we have. Okay, if this is what we have, so this only has 1 carbon, this one will have 1 and 2. However, we can't name it like that because an alcohol has higher priority than an ether. So in this case, the other one we're going to name it as 1 and 2 like that. Why? Because we're considering priority to what comes, which is the one that is on top. Now, what are we now going to do? So we just have to first name the smallest chain. The smallest chain, you're able to see that okay, so in this case, you're able to see that on position number 2, that's where we have a methoxy, okay, a methyl and an ether there. So in this case, we're going to have 2 methoxy. Okay, this on this side, it is an ethane. There's 2 carbons. So ethane, now ethane, if I put an E there, it won't make sense because this is an alcohol and we said we are prioritizing the alcohol. So this will be on position number 1, that's where we have our hydroxide, so it will be 1 O. So basically that is how you're going to solve this one. Okay, let's solve another one. Let's say you have this. Okay, so how are we going to solve this one? So this is one group, then we've got the other groups there. So basically, if this is our OH, let's say you have an OH there. So you know that OH in this case will be prioritized. So in this case, make sure that it is very close in the way you number it. So this one will be 1, the other one will be 2. Okay, so that is what we have. So how are we going to write it? Prioritize or substituent first. So we're going to have on position number 1, that's where you have the methoxy itself. Okay, so we have there on position number 1 we have methoxy or methoxy ethane. This is 1 on position number 1, that's where we have also there on position number 1, that's where we also have the alcohol. Okay, so in this case position number 1, so it will have 1 O. Okay, so that is the name. So 1 methoxy ethane 1 O. Okay, and that is very important. Let's solve another one. Okay, let's say this. Okay, let me put another one there and there, and I put like that, an aldehyde. So I have an aldehyde here. I have an alkene there. Okay, so initially our parent name is supposed to be hexene, okay, because of the double bond. So we're going to start with X. Now, how are we going to prioritize? Okay, we are going to prioritize out there. So this is 1, 2, 3, 4, 5, and a 6. So this would be hex. In this case, on position number 5, that's where we have a double bond. So I'm going to say 5 x5. Then this is an out. We said we are prioritizing the aldehyde, so in this case it's going to be in now. Okay, in now, out to mean x5 in now. Now in this case to mean, initially I was supposed to write it as hex 5 in, like we've been naming, alkenes. But now, because of the, when we don't want the Ne, this is for the alkenes. So we want the one for the aldehyde, with the one we are prioritizing. That's why we've put N now. Okay, hex 5 in now. Basically, that's how we are going to solve that one. Okay, so let's solve another one. Let's say we have this compound, and let's say this and that, and let's say we have something like this. Okay, then let's say this is an aldehyde. So how are we going to name it? Not very different from the previous one. So priority will go to the aldehyde in this case. So we're going to have 1, 2, 3, 4, and 5. So if that is what we have, so let's now name the substituents. So now able to see that on position number 2 we have a methyl. So I'm going to say 2 methyl. Now methyl what? We've got 5 carbons. So in this case, methyl pent. Now on position number 3, you're able to see that now we have a double bond. So I'm going to say pent 3. Now I'm supposed just to put in and another E, but I'm not going to put another E at the end because we have an aldehyde, and we said aldehyde ends in Al, so I'm going to put E now. So this is 2 methyl pent 3 E now. So basically that's how you're going to solve this one. Okay, so that is how we are going to solve that. Now let's also solve some about amines. Okay, now amines themselves, they are derivatives of ammonia. So you know that ammonia, it's just general formula. If you're going to talk about ammonia, so these are the aryl groups. Then you have a lone pair of electrons there. Okay, so basically that is the basic principle. Now if I just write the general formula for the general of an amine, let's say this is CH3NH2. How am I going to draw it? This is C. Okay, let me start with N. Your N in this case is connected to 2 hydrogens, just based on the formula. Then this hydrogen is connected to the carbon, which is connected to the hydrogen, to 3 hydrogens, Basically this is the structure, or you can write it as a dash connected to NH3. Okay, basically that is what we are going to have. So we have just have a methyl that is attached to the amine group like that. But now because we have a methyl in this case, this will be called meth. Okay, meth. Now that we've got meth, and we've said the way we name amine, the suffix that you're going just to use is amine. So this will be methamine. Okay, basically that is what you're going to get. Okay, so if that is what we have, so another thing that we can now write is, let's say, what if you've got how can we make it? Okay, even just like this, then you have an amine functional group there. So what are you going to consider? Consider the longest chain. So in this case, make sure that also it is very close to the substituent. So if you say 1, 2, 3, this is very far. 3 is very far to the subsequent. So you can just start from here, 1, 2, and 3. Okay, this is very reasonable enough. Now that we've got that, what are we now going to do? We've named, so since it's got 3 carbons, this will be acting like a propane as a parent name. But what is the name of this compound? So able to see that we're saying this will be propan. Okay, propan. Now on position number 1, that's where we have our amine. Okay, so this will be prop. On position number 1, that's where we have our amine. Okay, basically this is how you go about this one. Let's solve another one. Let's say you have okay, let's say you have this, and you have your amine up there. So basically what are we going to have? So even in this case, name according to the lowest subsequence. Okay, so if you start from here, you're going to find your amine at the position number 3, but if you start from here, you're going to find it at position number 2. So basically this will be 1, 2, 3, and 4, and that is what we're going to approach with. So basically this is because this is for the parent name is supposed to be butane, but now what is the original name now for this compound? So the original name now to be but or butan. Now where is the amine? Our amine is at position number 2. So butan 2 amine. Okay, basically that is how you're going to solve that one. Let's solve another one. So let's say this is NH2, this is OH. Okay, so how are we going to name this one? You know that alcohol has a higher priority. Thus, when naming, we're going to start to, in that direction. So in this case, since alcohol is the one with the highest priority than the amide, so this will be 1, 2, 3. Okay, because it is 3, the parent name is propane. Okay, but what is the name of this compound? So the name of this compound, you're able to see that on position number 3 there, we have a substituent. Okay, so in this case, I'm going to say 3 amino. Okay, because that is an amine. That's where we're finding the amine. So amino, this is propan, because it has 3 carbons. Then on position number 1, that's where we have our hydroxide. Okay, so I'm going to say 1 for the alcohol. So basically that is how you're going to solve this one. Okay, so let's solve another one. Okay, I'm thinking of one, but I can't find. Okay, basically I think these are much of what we've solved today. This was a very interactive session, so thank you. We're going to end from today. Other videos about organic chemistry are going to be posted. Thank you, and don't forget to subscribe.